Every once in a while, I'll get an email from a company asking if I want to try out one of their products, which is dope. However, some of the products they want me to try are not so dope. Luckily, a company called Seeed reached out and asked if I wanted to try out their Wio Terminal. Now, I've never heard of the company Seeed, and I've never heard of a Wio Terminal, so I had to do some Googling, and luckily I found out that Seed's actually a pretty legit company, and the Wio Terminal is actually a pretty cool little device. So I agreed, and they sent it over. Now, the Wio Terminal isn't like sending over a computer case or a router. This requires some creativity and essentially can be whatever you really want it to be and whatever you can code it to be. So I had some work to do. And what exactly did I come up with? Let's take a look. Okay. All right, let's plug it in. Look at that. Look at that. Real-time graphing of the CPU load on my home server. Okay, obviously it's not the sexiest thing or the most profound, mind-blowing thing, but it's something I wanted to do and something actually useful. So let's take a look at how I did it and my thoughts on the Wio Terminal as a whole. So yeah, these specs aren't going to blow you out of the water, but they're not designed to. This is designed to be a low-power, affordable microcontroller device that you can just play around with. So what makes this cool, I'm going to unplug it for a second, and what separates this from just buying like a little ESP board off AliExpress or something is it comes in a tiny package with a lot of built-in features. So it does have a 2.3-inch LCD. It has this nice little analog stick, so it can go up, down, left, right, and press. So you get 5 inputs there. You get 3 buttons as well on the top. And on the back, you'll see it does have a 40-pin GPIO plug-in. So this can actually act as an interface between itself and a Raspberry Pi. Around the side, also, you do get a micro SD card slot, and on the bottom, USB-C input and 2 serial device inputs. So there's actually a lot that they squeezed into this little device. I know the specs aren't super powerful, but there are a lot of sensors and add-ons you can add to this thing. They didn't send me any of those, but I've seen some people use those and create some cool things on this. That's essentially it. I can't believe I forgot to mention it does have a Wi-Fi chip built in. It has a Realtek, some model number, Wi-Fi chip built in, which makes this really convenient to interface with your home network or any IoT devices you have. So to program this, you have to do it in Arduino or MicroPython. There's also ArduPy. I've never heard of that. I guess it's some version of Arduino and MicroPython put together. I don't know. I actually used Arduino because I read that if you want to use the Wi-Fi chip on here, you have to use Arduino. You can't use MicroPython, so that's what I did. So what exactly did I do? Let's plug this in and I will show you what it is that I made. All right, when you first boot it up, it's going to load a list of devices within your home network. Now, this is a static list of devices that you've installed my API on. I'll get to that in a second, but this is where you basically specify. It gives you a list. You can scroll up and down to select which device you want to look at. For example, let's take a look at my server. You can click the button, or you can go to the right, whichever you prefer. Then it will give you a list of options of what you'd like to monitor or look at. So there's CPU, CPU temperature, CPU load, BIOS, RAM, and network. There are a lot more options in the actual API, but some of those either aren't necessary or way too cumbersome to parse out on this little device. So I just stuck with these for now. Now, yes, I know the UI, the GUI isn't mind-blowing. I've seen people make some pretty cool little GUIs on this thing, but this is 2 days of work. If I wanted to put a lot more time into it, I'm sure I could create a better looking GUI, but I just don't care. So, okay, let's check out the CPU. Let's do temperature. So if I click on that, it comes back with a main temperature and a max You can see it's at 40 degrees Celsius, and the cool thing about this is if I click that again, it will now graph that in real time. So it looks like we're just hovering at 41.3. No changes. Up, we dip down a little bit. This is updates every 2 seconds, so you can leave this up, have it monitor something. If you want to set it up to do alarming, you can do that. There's a lot of potential in this, but this is just really base functionality that I wanted to share. So cool. You can go back. Now, cool thing about this API is that it works on pretty much all your devices. So whether that's a Linux-based machine, a MacBook, a Windows device, Raspberry Pi. I actually have examples of all that. So if we scroll down, you can see I have it running on a Raspberry Pi. So if we check out the CPU, you can see manufacturer, Sony UK, whatever that means, the brand, BCM 2711, some information about the processor, 4 cores, 4 threads. Go back, we can check out the RAM usage. So I have the 8GB version, so you can see we have a total of 8GB here. Makes sense. If you want to graph that, you can. So this is going to show you your amount of free RAM available. Again, just like every other one, you can graph these numbers in real time. One cool thing on here is that if I go into my server, it has information about the BIOS, which is pretty cool. I can think of quite a few times actually where I needed information about the BIOS. I didn't feel like remoting in or doing whatever, SSHing in, finding out information, blah, blah, blah. This, you could literally just pull this up and find out information about the BIOS in a couple seconds. So an actual use case. So basically how this works is the code on here is sending out HTTP GET requests to an API that's running on each device that I want to monitor. Now, this is all coded in Arduino, which is C++. Ugh. The API, however, is a NodeJS API. It's literally like 60 lines of code. I'll show you guys in a minute. Super simple, super streamlined, lightweight, easy to install. Awesome. So use cases for this. The main use case is, for example, say you're in your room coding and all of a sudden someone breaks in like, hey, I'm a bad guy. And you're like, oh shit, yeah, I'm gonna beat you up. Oh, please don't. Oh, okay. I guess I won't, but you have to do something. Oh, what? You gotta show me what your server CPU usage is in real time. Okay, I can just pull this up over. No, you can't use a computer. Oh, okay, hold on a second. Okay, I made this. This will show it to you. Oh, nice. That's pretty cool. Yeah. Yeah. Okay, can you leave now? Oh yeah, sorry. Have a good one. Okay, more realistically, I think use case for something like this would be to set this up in an office or even a home lab scenario where you can easily monitor specific machines. You can even set this up in the API up to send you emails where it monitors maybe the CPU temperatures and can send you emails. Now, yes, I know there's a lot of programs that do that already. Some are free, some are paid, but the satisfaction of using, cheaper, smaller hardware and developing your own kind of thing, it's something a lot of people like to do, including me. So let us enjoy things. Okay, so we are going to hop into the code. If you really don't care about this at all, you can skip ahead to the end where I give my final thoughts about everything. But if you're a mega nerd or want to see the code and you're a code pervert, let's do it. All right, here's the code. The left side is the Arduino that's physically running on the Wio Terminal, and the right is my NodeJS API. So let's take a look at the Arduino code first. Now, if you don't have any experience coding in Arduino, I wish I could say it doesn't suck, but I hate C++. You might have a different worldview on that, but anyway, this is the code. I'm going to go through it. I'm not going to spend a lot of time on this because I'll have all the code available for download somewhere in the description below, but when you first turn it on, it's going to run this setup method. This section right here, this is just communicating with the LCD screen, saying begin. You have to rotate it and pass parameter 3 to have it kind of that right side up. And set the text size, create the sprite. This is for the graphing. Pin mode, actually this is left in. I don't think this is necessary. Wi-Fi connection. So this is where you specify your SSID and password. That is declared over here in my other custom headers file. Then it's going to do some pin mode stuff, making sure we understand when we press the up, down, left, right on the analog that it actually does something. Then we are going to run our first method that actually lists all of our stuff. After that, it's going to run this loop function over and over. This is where it's kind of waiting for an input, and depending on if you're pressing up, down, left, or right, it will do a certain task. So I'm not going to walk through each of this. It's basically saying, if you press down, go to the next option and then redraw the screen. Remember, this isn't like a WPF application or a fancy web app with a bunch of, custom JavaScript frameworks that you can use. This is very bare bones. Then it's doing some fancy stuff with the graphing to make sure it still recognizes inputs, blah, blah, blah. Here's the different functions. They're all doing relatively similar things. So draw PCs means like basically draw devices, list our devices. It's going to go through the list that we specified. Hardware options, very similar. I hard-coded the options that I want to list. Draw hardware specs. This is where it's actually going to take your selection of what you want to see and call the API. So this one's a little more robust. It's calling this, where is it? Get value function. I know, really clever. So the get value function is what's actually hitting the API. It's making sure our Wi-Fi status is actually connected. If it is, it's going to make this HTTP request using this URL that we build. Basically take the IP of the device you selected, the port you have it running on. The API is listening on the /system syntax. And then you pass the call you want, and then extras is if you want to only specify a single option. So it does all that, it gets the data back, blah, 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 and then you have this available to use later. It does some JSON parsing using a Arduino JSON library, and it does that here. Creates a JSON document, deserializes it. Then here we just have a parameter. Certain ones are formatted differently. Certain ones have different JSON formatting. In other more advanced coding languages, I wouldn't have a problem with this. Parsing JSON is just a lot easier, but in here, it's not very fun. So then it just goes down here and lists all that information and kind of does a thing where you can select them. That's all done here. Blah, 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 blah. Same thing for the graphing. If we scroll down, the way it graphs, very similar. All this is essentially the same. Get the data. But here we're actually using the line chart library supplied by Seeed, which is extremely useful. You don't have to code your own graphing. And essentially this is the syntax. It's pretty easy. You specify value. We get that here. We declare it. We add that to a stack right here. And then it's just using that stack as a data source and drawing the chart. And this is just getting called over and over when we're on the graphing option. And that's kind of it. I'll go over here to custom. So here's where I specified essentially all my global stuff. I could have just put that in the main file, but I like this, it's cleaner. So here's where you can see I'm specifying my devices using just a simple struct that I created up here. Down here you can see the options. That's very similar. It's a different struct with just an added parameter for if I want to remove the base object from the JSON object that it returns. But here you can just see some generic global variables that I declared. I just don't like C++ Arduino just because I'm used to really not efficient coding where you don't have to specify exact memory allocation that you want to use. But in Arduino, that's a whole different animal. If you want to specify, or if you want to create, a list, you have to specify the size of it first. And if you don't, you run into some overflow errors. And I am obviously not a C++ expert. So if you are and you're looking at this and vomiting, I apologize, but it works. And that's essentially it. If you want to modify this, all the code, like I said, is available to download. You can download it and play with it, mess with it, fix it, break it, do whatever you want. Turn around, put it on your face. I don't care. That's it. Let's take a look at the API. So the API is in NodeJS. It's extremely simple. It's, let's see, about 50 lines of code. And the main base of that, I am not taking credit for. This is using a library created called System Information. This is essentially a Node.js library that you can utilize in your JavaScript code, which gives you a crap ton of information about your system. So I showed you before, we were looking at the CPU, memory, there's some network statistics. There's a lot more here, as you can see. You can look at battery, graphics, disks, input and output, and all information about your disks, Wi-Fi, Docker containers that are running. There's just so much here. It's extremely impressive, and a huge shout out to Sebastian Hildebrandt. If you're going to use this, I recommend at least dropping some support, a couple of dollars, because it's free, and this is a very powerful and extremely useful piece of software. So major props there. But let's take a look at the code that I am running it with. So this is the main file. This is the app.js file. We are using Express to host our API, and we are using another file. This is the api.js file that's kind of built the API. But all this is doing is creating our Express process that is going to run. It's going to listen on port 3000. And we essentially have two syntaxes to hit for our API to get requests. We have one that follows the system/object/param protocol. Then we have one for just system/object. And if we go over to the API, you can kind of see how it's interacting with that system information. You can see we're using the system information library. Here is where I am defining a list of objects that I want to send back for each call. So you can see for each of these, I'm only listing a few things that can come back, and that is because you get a lot of information back when you call, for example, CPU, and a lot of it is either information that you really don't need, or a lot of it's just stuff that I didn't want to have to parse through the JSON object of. And again, we're working with a tiny little 2.4-inch LCD, so I wanted this to be lightweight and easy. But this is it. It's either get item or get item simple. Simple follows this kind of protocol right here for the API. We send over our object. It creates this value object, which is what the actual system information API takes. It returns that using the system information.get method, which is a promise. So it's asynchronous. And it's just going to return that back to the app and then return that from the Express HTTP request. So now you have a JSON formatted response, and you're free to parse that on your terminal. So that's it. I mean, that's the code base. And the cool thing about this API is that once you have it set up, you don't have to use it just on that Wio terminal. So for example, if I run this now, we can just open up a page, and I can go to localhost 3000/system/CPU, and you can see this is what's sending back to the Wio terminal. That's the API call that I use. But remember, I had two, so I can also specify, I can say all, and here's all the information about our CPU. And here you can see this is why I didn't want to send all of it back to the Wio terminal. This is just a lot of information for that tiny screen. And there's just so much here. Like, you can look at disk layout, and I'll show you a bunch of information about your disk. So you can see what I have: a 1 terabyte SSD in here. I have an M.2 SSD as well, and then a Western Digital, I guess this is another SSD. So this is a terabyte, this is 512, and this one's 256. So a lot of information. I'm not going to dive into the entire API. I will put a link to this in the description. You can check it out. There's a lot of good documentation in there, major props. So, but yeah, that's it. Final thoughts on this device. I like it. I'm a tinkerer. I've done quite a few projects with a Raspberry Pi before. I know I haven't done much on this channel about it, but I do like to tinker with stuff, whether that's hardware or software. So this is right up my alley. I think what makes this actually great and separates it from a lot of products on the market is that it packs all the necessary things you need for kind of a tinker device into a compact, efficient layout. Now this is $37, so I mean, an ESP little microcontroller is about $5, but you don't get, you know, a light sensor, Wi-Fi enabled, storage expansion, a built-in screen, and, you know, what, 9 inputs, which is extremely underrated. There are a lot of times where you want easy user input, but it's something you have to physically build out yourself. So having all that built in right here is pretty neat. And while using it, my watt meter wouldn't even register it because it literally sucks under 1 watt while using it. So extremely low power. This is a pretty big power bank. This will run it for probably weeks. But yeah, awesome little device. Definitely recommend it. If you are a seasoned tinkerer or want to start, I think this is a very good place to do that. So I'll leave a link to the Wio Terminal page below. But if you have one of these, let me know what you've done with it. I've seen a lot of projects out there that are really cool. I know the potential is much higher than what I've done here. So I'd be interested to see what you do with yours. Or if you don't have one, what are some ideas? Because I'm definitely open to another project on here. So let me know down in the comments what you think. But that's all I have for you today. If you like this video, please drop a like below. If you like content like this, please subscribe. Thank you so much for watching, and I will see you in the next one.